Built at a cost of over £1 million and covering more than 1 million square feet, the Banner Lane factory is one of the finest in Europe. It comprises 4 main buildings. The design, research and experimental departments occupy one main block. Number 1 machine shop produces gears, shafts and other components for the gearbox and differential assemblies. Number 2 shop supplies the larger castings with small machined items. And the main assembly shop, where the tractor is built up from component parts. All the buildings are connected by an extensive conveyor system which delivers finished components from the machine lines. Many of the machine parts start life as stampings, and to ensure a steady flow of these to the production lines, large stocks are maintained. After aging for some time in the open, they are transferred to the raw material stores, where they assume a more orderly appearance. Here is one of the 5 continuous annealing furnaces which are installed in the stores department. The stampings to be treated are loaded into special trays, each of which accommodates 170 pounds of work. It takes 10 hours for the work to pass completely through the furnace, during which it attains a maximum annealing temperature of 950 degrees centigrade. Baffles inside the furnace control the rate of cooling. After annealing, the stampings pass on gravity roller conveyors to the machine lines. Crown wheel blanks are loaded onto a Bullard 8-spindle multomatic machine. Each piece is securely clamped at the loading station and then moves progressively round to each of the 7 machining stations. 10 turning operations are accomplished in one complete cycle. On a similar machine, the reverse side of the crown wheel again passes through 7 machining stations, where 11 turning operations are made automatically. Each machine produces 30 pieces in 1 hour, thus maintaining the 2-minute time cycle. "12 rivet holes are drilled by this Archdale multi-drilling machine. The components again rotate to 3 operating positions, where countersinking and finish reamering are also carried out. This means the first piece is drilled, the second countersunk, and the third reamered to finished size simultaneously, making a total of 36 operations with 1 descent of the machine head. The grinding operations are accomplished on this Keithley grinder, which works to a tolerance of 1/1000th of an inch. First, the surface is ground, and then the bore, both being achieved with a single setup of the component. Further along the conveyor lines are the Gleason hypoid roughers and gear finishers. After the crown wheel blank is placed on the machine, it is clamped into position hydraulically. The tooth slots are obtained by a circular cutter which withdraws after each cut to enable the blank to move into the next position. The gear teeth are finished on a similar machine. Each tooth space is completed by a single revolution of the cutter, the whole gear taking 6.5 minutes to complete. The crown wheels are now ready for heat treatment. In the carburizing section, the parts are packed into boxes between layers of charcoal compound and placed in the oven for 12 hours at 900 degrees centigrade. 12 recuperative type furnaces are needed, and these handle a total of 1,500 weights of work in 1 hour. The boxes are withdrawn by a mechanical loader and left to cool before unpacking. The parts are now placed on open trays and fed again into the furnace for refining. This time they will remain for 30 minutes at 875 degrees centigrade. The mechanical loader is transporting a batch of drawbars to the oil quenching tanks, where they're quickly submerged in mineral oil. This causes the parts to cool fairly rapidly, thereby hardening and refining the steel. It also toughens the texture, which increases its resistance to withstand shocks. Returning to the crown wheels, these are withdrawn and left to cool in the air. Next comes the hardening process. The parts are placed into the walking beam conveyor, which feeds the work continuously through the furnace. This takes approximately 1 hour, during which a constant temperature of 780 degrees centigrade is maintained. These combined treatments will ensure a very hard, wear-resisting outer surface to the teeth, combined with an extremely tough inner core. Each wheel is placed in a Gleason press, where it is quenched in oil under a pressure of 50 pounds per square inch to prevent distortion during the cooling. After this, they're transferred to the final heat treatment, which consists of tempering at 200 degrees centigrade for a period of 1.5 hours. After shot blowing to remove the scale caused by heat treatment, the wheels pass to the plating section. Here they are suspended in the vats to acquire a coating of copper. The time varies from 2 to 6 minutes, according to the thickness of copper deposit required. Cadmium and other plating processes are also catered for in this section. The parts having received the necessary thickness of copper deposit are removed to other tanks and thoroughly washed before passing to the assembly section. Copper plating is used to facilitate the running in of mating parts. Here are a few typical components on which the process is used. The finished crown wheel is assembled in the differential box. Rivets are placed into position prior to being forged over by a special electric riveting press. The heat is applied electrically when the electrode comes into light contact with the rivet. As the correct temperature is reached, hydraulic pressure is automatically applied, causing the rivet to spread over and securely fix the two components. The electrode is water-cooled, and the whole machine operates by a single pressure of the foot switch. This is the machine blank of the crown wheel driving pinion, ready for the teeth to be cut on the Gleason hypoid roughing machine. These machines are the first of this type to be installed in a European factory and have a greatly increased output over previous production methods. The teeth of each pinion are completely rough cut in 4 minutes. Two similar machines are used for finishing, one dealing with the driving side of the teeth and the other with the coasting side. After this, the pinion will pass through heat treatment similar to the crown wheels, comprising carburizing, refining, hardening and tempering. A final coating of copper plate completes the work. This type of Fellows planetary gear shaper was probably the first to be used outside America. 6 gear blanks at a time rotate round the circular cutter, which has 3 graduated cutting sections, these being rough cut, semi-finish and final finish. One revolution completes the cutting of the teeth in 10 minutes, which means one finished gear leaves the machine in every 100 seconds. A broaching machine cuts the splines on the inside diameter of the gears. 2 graduated cutters are pulled slowly through the gears. The first does the rough cutting, and the second progresses from semi-finish to final finish. Each machine shop is self-contained and has its own heat treatment plant. In the gear section, 8 cyanide furnaces deal with 2 tons of parts in 1 hour. The gears are hardened at 800 degrees centigrade and cooled by quenching in oil. They are now thoroughly cleansed by passing through 2 hot water baths and finally tempered for half an hour at 200 degrees centigrade. Following the most modern production techniques, Standards installed one of the first wheelabrator shot blast units. Fed by a monorail pendulum conveyor, the larger castings rotate past 4 staggered wheelabrators, which throw the shot with tremendous centrifugal force against the parts. This removes the scale and rust, preparing the castings for prime dip painting. The plant, operated by 4 men, handles 12 tons of work in an hour. Using previous hand methods, 24 men would be needed, using 12 cabinets. An air-operated lift raises the components to the monorail conveyor, which feeds the prime dip paint plant. Once attached, they require no further attention and pass automatically through the paint vat, draining channels, and drying ovens. Painting the castings before machining eliminates the possibility of covering machine surfaces with paint, and consequently the necessity for its removal. After dipping, the conveyor pursues a switchback course over the drain channels and is long enough to allow a draining period of 25 minutes. Hooks of varying lengths control the depth of painting required. Once again, by careful planning, a tremendous saving in man-hours is obtained, giving a greatly increased output at a lower cost. After traversing the drain channels, the components are dried by remaining for half an hour in the drying oven. Transmission cases made of electron are distinguished from those of cast iron by being sprayed with yellow paint and are conveyed direct to the drying oven. Finished parts are delivered from all sections of the works to the main stores by monorail conveyor, where they are stored on gravity-feed roller tracks. These slope towards the center, where parts are loaded onto the overhead conveyor serving the assembly lines. The functioning of the stores can be compared to that of a railway marshalling yard. The finished parts received from machine shops and outside suppliers are arranged in convenient order on the roller tracks. They are then collected in the right quantities and placed on the conveyor trays in the order required by the assembly lines. The conveyor passes through all the sub-assembly sections and along the main assembly lines, delivering the necessary parts to where they are needed at the right time. The empty trays returned by the endless monorail conveyor to the stores for reloading. This system entirely eliminates delivery by trucks and manual labour and keeps the gangways free from congestion. Accurate timing of the deliveries is vital, and the feed conveyor is carefully synchronized with the assembly lines. The parts leave the stores at high level and descend to floor level in the various unloading points. The transmission case arrives at its appointed assembly station. Fixing studs are placed in position and screwed home with an electric power wrench. Where the yellow-painted electron cases are used, a chromate solution is applied to the mating iron and steel parts to prevent corrosion from contact. The main assembly track is of the endless steel slab type and carries support brackets to which the transmission cases are transferred. Pedal shafts, brackets and other items to be fitted at this point arrive at the precise moment they are required. All the careful planning and research, the precision manufacture and rigid inspection culminate at this stage in the rapid assembly which proceeds like clockwork. The gearbox, comprising 4 forward speeds and reverse, is built up from small sub-assemblies. The reverse gears and lay shaft are fitted first. At the sub-assembly station, the parts are removed from the conveyor and the roller bearing is forced onto the main shaft by a small hydraulic press. The fine machining limits observed during manufacture enable the driving gears to slide with smooth precision over the main shaft. All the parts match perfectly and the entire gearbox is assembled in 20 minutes. The centre housing, mounted on a wheeled carriage, proceeds along a subsidiary track adjacent to the main line. The rear axle casing is mounted in position and the bolts driven home by a power wrench. The whole unit swings over in readiness for the next operator, who fits the oil seal gasket. The crown wheel assembly is lowered onto its bearing and rotates freely. The other rear axle casing is fitted, and the unit passes with the crown wheel pinion to the next operator. The swing-over type carriage allows the unit to rotate to the position best suited for attaching each individual component. The hydraulic pump, virtually the nerve center of the tractor, is fitted to the underside of the tractor, which at the moment is uppermost. This pump supplies oil under pressure to operate the hydraulic lift unit, which is assembled near to the main track. The function of the lift unit on the completed tractor is to raise and lower the plough, or whichever implement is in use. It is actuated by the forcing of oil into the cylinder by the pump. The hydraulic system also automatically controls depth and prevents damage by obstruction. Power hoists are used extensively, and the hydraulic lift unit is lowered into the center housing. This completes the assembly of the unit, which is ready for attachment to the transmission housing, now approaching this point as it proceeds along the main track. The unit, still mounted on the carriage, is wheeled to meet the transmission housing. Winding gear adjusts the height to register the attachment points. Meanwhile, the engines, which have been manufactured at the company's engine plant at Canley, arrive at the assembly shop. Here they are suspended from an overhead conveyor, which enables large stocks to be held without causing congestion. Mounted on trolleys, they move to meet the growing tractor. The oil seal gasket is fitted and the engine offered into position. With the narrow conveyor track supporting only the center unit and the engine and rear axle overhanging on either side, the operators can work all round the tractor without hindrance. The front support bracket, which will carry the radiator and front axle, is attached and secured with ratchet spanners. The rear axle shaft and brake shoe assembly are fitted as a unit. The axle beam comes next, and onto this are built the front axle details. The radius arm is placed in position, and then the axle arm, which will carry the front wheel. The near and offside track rods are next. Followed by the radiator. "14-inch diameter brake drums are fitted to the rear axle. And so the assembly proceeds apace, rapidly approaching the halfway line, where the tractor will temporarily leave the assembly line and pass through the paint section. Overhead lift gear hoists the tractor and moves it to join the monorail conveyor which feeds the spray booths. The painting is carried out at this stage before the battery, electrical gear and certain other details are fitted, as these cannot be subjected to the high temperature of the drying oven. The tractor passes through 2 spray booths where the alternate sides are painted. It then enters the drying oven, where it circulates for 30 minutes. The delivery rate to the stores of details supplied by outside contractors is controlled by the Material Control Department, which regulates the supplies to suit the immediate demands of the assembly lines. The rear wheel fenders are delivered by motor truck direct to the stores, where they are placed on a monorail conveyor. The fenders, bonnet and other details to be painted are conveyed through the vat drain channel and drying oven without further attention. Having previously received an undercoat of priming paint, the parts now acquire a finish coat of Ferguson grey. On leaving the vat, the parts pass along the usual drain channels. After 30 minutes in the drying oven, the conveyor passes the components direct to the assembly lines. The tractor wheels and tires are stored on roller tracks. This enables them to be fed continuously to the overhead conveyor, which supplies the wheel fitting station. The painted tractor leaves the drying oven and descends to join the second part of the main assembly line. The various links which carry the farming implements are attached. An 18-inch diameter wheel controls the steering, the adjustment of which is not affected when altering the width of the variable front track. A dust-proof air cleaner is used. The petrol tank has a capacity of 8 gallons, with a reserve of 1 gallon held by a two-way valve. A 6-volt battery is fitted, which supplies the ignition and the automobile-type self-starter. Greasing is by the calamite pressure system. The tractor is ready to receive petrol, oil and water, which is supplied from nearby pumps. 1 gallon of petrol is sufficient to carry the tractor through the final test. The tractor leaves the end of the assembly lines and is transferred to the wheel fitting station. The hydraulically operated jacking cradle rises to support the tractor whilst the wheels are attached. A set of wheels has been delivered from the stores by monorail, and the large rear wheels are mounted on special trolleys. These are guided into position by floor rails and simplify the handling of such heavy items. The front wheels are more easily attached, and the power wrench gives correct tension to the fixing nuts. As the jacking cradle withdraws, the tractor stands on its own wheels. The self-starter switch is operated by the gear lever and so eliminates the possibility of starting the engine when in gear. After the seat pan is attached, the tractors pass to the testing stations, which are separated by sound-absorbing partitions. And at intervals of 2 minutes, a new tractor bursts into life to pass through the final stages of production under its own power. The hydraulic lift system undergoes a rigid test. A special harness is substituted for the farming implements and attached to the tractor links. The harness carries a load of 600 pounds which is accommodated in a pit concealed beneath the floor. The control lever is adjusted, and with the hydraulic pump in operation, it must be possible to raise the attachment levers to the highest position in 5 seconds. It must also be capable of maintaining the heavy load in the fully raised position, which in 5 minutes must not fall more than 1 inch. From the test station, the tractor is driven to an endless slat conveyor, where final adjustments are made. Nearby, the radiator grille and bonnet are assembled. This is the last sub-assembly, and when fitted in position, the assembly of the tractor is complete. During the 20-odd years of development of the Ferguson system, Mr. Ferguson has always believed that transport on the farm is one of the most important jobs.